Welcome to The Explainer. Today, we are diving into the global race for quantum supremacy, a technology so powerful it's turning science labs into the new geopolitical battlegrounds. Seriously, the nation that masters this could hold the keys to the entire 21st century, and the competition is already white-hot.
And this isn't some friendly scientific competition. It's a titanic struggle, with the United States and China as the main heavyweights. But, as we're about to see, they are definitely not the only players in the game. The prize? Oh, just the future of economic power, military advantage, and pretty much total technological dominance. No big deal.
So, what is all the fuss about? What are they actually fighting for? To really get a handle on the huge geopolitical stakes here, we first have to understand the tech itself. And, well, it all starts in a very, very strange world.
So let's pull back the curtain and try to demystify quantum technology, starting with its most basic building blocks. It's a world that operates on rules that seem to defy common sense, but believe me, their power is absolutely undeniable.
Okay, it all begins with this thing called the qubit. You can think of it as the quantum version of a regular computer bit, but here is the absolute game changer. A normal bit is stuck. It's either a 0 or a 1. That's it. A qubit, though, because of this wild property called superposition, can be both a 0 times and a 1 at the exact same time.
This is really where the magic happens. That ability to be in multiple states at once, superposition, is what unlocks this incredible exponential power. So imagine you're trying to find one specific grain of sand on a huge beach. A classical computer would have to check each grain one by one by one. A quantum computer could, in a way, check them all at the same time.
And then there's the next piece of this bizarre puzzle: entanglement. This is where two or more qubits become deeply, mysteriously linked. Whatever you do to one qubit instantly, and I mean instantly, affects the other, even if they're on opposite sides of the planet. Einstein famously called it spooky action at a distance, and that's exactly what it feels like. It's this property that lets quantum computers weave together an insane number of calculations all at once.
And you know, this race isn't just about building faster computers. It's really a three-front war. There's quantum computing, which is perfect for code breaking. Then there's quantum communication, promising completely unhackable networks. And finally, quantum sensing, which could detect things like submarines or stealth aircraft with a precision that honestly sounds like something out of science fiction. Every single one of these is a total game changer for national security.
But this isn't all just spy games and military strategy. This same tech could fundamentally change our daily lives for the better. We're talking about designing life-saving drugs in a fraction of the time, creating super-accurate models to fight climate change, or building ultra-secure communication for future space missions. This is exactly why this race matters to every single one of us.
So who are the key players in this high-stakes global competition? Let's take a quick look at their different strategies and, just how much cash they're throwing at this to try and win. Right now, we're seeing three very different playbooks emerge. The U.S. is betting big on its private sector giants, your Googles, your IBMs, backed by federal research grants. China has taken a completely different path, a centralized whole-of-nation assault with massive state funding. And the EU? They're pooling their resources, focusing on multinational collaboration to achieve what they call technological sovereignty.
And when you look at public funding alone, the scale of China's ambition is just staggering. Its estimated $15 billion plus investment absolutely dwarfs the others. But, and this is a huge but, this chart doesn't show the billions and billions being poured into quantum R&D by private companies in the US, which makes the true financial picture a lot more complicated.
And hey, this isn't just a three-horse race. Other key players are making really serious moves. The UK, a true pioneer in this field, is still a powerhouse. India has launched its own ambitious national mission. And countries like Russia and Canada are also determined players with deep, deep roots in quantum research. Let's just say the field is getting crowded.
Now, despite the billions being spent and all the breathless headlines, we need to be realistic. We are not on the verge of a quantum-powered world tomorrow. There are some immense technical and, frankly, ethical challenges that still need to be solved.
So here's the brutal reality of it. Qubits are unbelievably fragile. I want you to imagine trying to have a very quiet, whispered conversation in the middle of a loud rock concert. The slightest vibration, the tiniest change in temperature, what scientists just call noise, can make a qubit completely lose its quantum state. That process is called decoherence, and it is the single biggest roadblock to building large, reliable quantum computers.
And fixing those experimental errors is just one piece of this gigantic, complicated puzzle. I mean, scientists are still wrestling with the fundamental theory behind it all. Engineers are still figuring out how to operate these things outside of a perfect, pristine lab. And then there are the massive hurdles of just making them affordable and accessible enough to actually be useful to anyone.
And this brings us to a really critical point, which is captured perfectly by the researcher Ravi Rao. The challenge isn't just about making the tech work. It's about making sure it works for humanity. And that means we have to stare down a potential ethical minefield.
Just think about it. The same power that can break encryption can also enable surveillance on a scale we've never seen before. There's a huge risk of creating an even wider digital divide, a world of the quantum haves and have-nots. And we also have to talk about the environmental cost. The complex, energy-guzzling cooling systems needed to keep these qubits stable have a pretty significant carbon footprint.
All of these challenges, all this competition, it's all hurtling towards one single, incredibly high-stakes finish line that is driving so much of this geopolitical urgency. It's a moment in time that security experts simply call Q-Day.
So what is Q-Day? It's the day of reckoning. It's the hypothetical day when a quantum computer becomes powerful enough to shatter the encryption that protects nearly everything in our digital world. We're talking everything from your bank account and your private messages to top-secret government and military communications.
And here's the really scary part. The threat is already here. It's widely believed that adversaries are actively sucking up and storing huge amounts of encrypted data today. They're betting that on Q-Day, they'll finally have the quantum key to unlock it all. The strategy is chillingly simple. Harvest now, decrypt later.
So how urgent is this? Well, a concept called Moska's theorem gives us a terrifyingly simple way to think about it. It goes like this. Figure out how long your secrets need to stay secret. Then add the time it'll take you to switch over to quantum-proof security. If that total number is bigger than the number of years until a powerful quantum computer is built, then your data is already at risk. It's already too late, and for many government and corporate secrets, that deadline has probably already passed.
Okay, the good news is there is a global defense plan taking shape. The world's top cryptographers, led by the U.S. National Institute of Standards and Technology, or NIST, have been working hard on a new generation of encryption. It's called post-quantum cryptography, or PQC. And these are basically new math problems designed to be secure against both classical computers and future quantum computers. Governments are already starting to mandate that everyone switch over.
And this brings us to our final and maybe most important question. This whole quantum race is being fueled by incredibly fierce competition, but securing our future from its biggest threats is going to require unprecedented global collaboration. So can these two opposing forces actually coexist? The answer to that question will likely define our security, our economy, and our society for the next 100 years.